So I am being recorded. I don't like to be recorded, just to be clear to anybody watching this over the recording, because it means I can't be as candid as I might like to be at times. I really like to make fun of IBM, but you know, if I go too far on a rant, then it gets recorded, and you know that always comes back on me. So I'll do my best to keep it on the straight and narrow. But if it looks like I'm pausing and I really wanted to say something but don't, you can blame the fact that this is going on the internet, I guess. Is there anybody from IBM here tonight, by the way? No, oh, see, that's such a shame. Opportunity lost there. All right, so, oh, and I meant to ask, is anybody here going to QCon? Does anybody here? Yeah, okay, that's good, because man, that would be hardcore to spend the whole day at QCon and then still go to a JUG meeting later. But anyway, that's why I'm in town, and so I doubly appreciate the opportunity to speak here tonight. You know, so I can kind of check another reason to travel to London. So I'm actually based in Ottawa, Canada. So you'll hear me, you know, took a boot, you know, oot and a boot and all that kind of stuff. So the Canadian accent does come out at times, especially when I'm as exhausted as I am right now. I've worked at Oracle since 2002, but in between I spent 6 years working at the Eclipse Foundation. So I don't know if any of you use the Eclipse IDE or have any involvement in any Eclipse projects. But I spent a few years in the middle there. I went back to Oracle in 2011, just after the Sun acquisition had closed, and Oracle was looking at, you know, we have Java SE, we're trying to integrate this into the Oracle ethos. We need somebody that understands open source and the Java ecosystem, this, you know, understand, you know, how Sun Microsystems used to work and so on. And so that was kind of a great opportunity for me, and I've been running Java SE product management ever since then. Okay, so that's a little bit about me, a little bit about my biases. I will warn you too that I'm not going to be doing coding demos. I'll be talking, you know, higher level slideware type stuff. If you were hoping for some code stuff, I can get you lots and lots of references, or we have lots of other speakers who would be certainly happy to come through at some point and talk about in detail some of the more technical features. So I do have to put this up, the standard Oracle Sarbanes-Oxley disclaimer, because undoubtedly some of you are Oracle customers, and we wouldn't want there to be any doubt that anything I say here is entering into a verbal contract. I always hate talking about this slide, but on the other hand, I will point out that our Sarbanes-Oxley slide is way more concise and readable than IBM's. All right, so lots going on in the Java ecosystem. You know, we've been working for many years making Java more and more open, constantly driving the technology. We've realized in the last couple of years we have to be more nimble at bringing features to market, so we've been working on that. And also scalability. So, you know, we are seeing statistics about, you know, people running trillions of JVMs and running, you know, into petabytes of data. And so we need to make sure that our solutions are scalable. So those are kind of the key driving areas. Before I go into the slides and go into the new release model, I do just want to take a step back and just kind of forget the slides for a minute and just summarize. There's kind of three things that have been going on in the Java ecosystem for the last 2 years. And they're actually independent events, but they can easily get conflated and confused together, especially if you want to form a grand conspiracy. And sometimes I wish I was as smart as people think I am with these grand conspiracies. I assure you it's not how it works. So we have these three separate things. So the first thing, and I'll talk about each of these things in more detail later, but I just want to get that out there first. Number one is we are going through the end of public updates of Java 8. All right, so what that means, and this is an Oracle thing, what that means is Oracle is going to stop making publicly available free commercial use updates of Java 8. Okay. This is not a new thing. This is the way the Java ecosystem has worked since well before Oracle in the Sun era. It's how Java gets funded. It's how we fund the development of the Java platform. So let's travel back in time. We have Java 5 released. Everybody's using Java 5. Java 6 comes along. After a bit of time, Sun says, if you want Java 5 updates, you need to be a Java for Business customer. All right? And if you want the free stuff, you use Java 6. All right? And then Oracle acquires Sun. We go through the end of public updates of Java 6 because Java 7 is available. And the headlines are Oracle starts charging for Java. The worst fear that we were all expecting when Oracle bought Sun, that they're going to start charging for Java. The end of public updates of Java 6 and pushing people onto Java 7 was exactly the same pattern that Sun had been going on before. We cannot afford to maintain updates for free for 8 different releases of Java, right? We have to draw a line somewhere. And so the current stuff is free. The old stuff, if you want to stay on the legacy releases because you have an app in production, that's where we want to monetize, right? And that has been the business model for a very long time. So we're going through that right now with Java 8. It's a little different with Java 8 because of some of the stuff with the desktop. So we're still going to provide free updates of Java 8 for consumers and individuals, for developers, testing, QA, but not for production commercial use, right? So it's end of public updates, except if you're in one of those other categories. So Java 8. Okay, so that's the first thing that's happening. We are going through this long-standing practice of end of public updates of Java 8. The second thing that's happening is we've changed the release cadence. So we used to have these massive releases with hundreds of spec-changing features we would say 2 years, but it was always every 3 to 4 years, and sometimes 5, right? And that worked well in the 90s, and it worked well in the early 2000s, and even as recently as 2010, it was probably still okay to have a release cadence in the 3-year time frame as a platform. But with modern application development, with continuous integration, continuous deployment methodologies, with the cloud and mobile taking hold, there's just no way for Java to continue its relevance for the next decade if we were on these 3-year-long release cadence, right? It's table stakes. I'm unapologetic about switching to a 6-month release cadence. We talked about a 6-month release cadence for years at OpenJDK with all the contributors to OpenJDK, at the JCP, because we had to streamline what was a multi-year JCP spec process into a 6-month iterative process. So that took a lot of conversations, and everybody agreed in OpenJDK and with the JCP that this made a lot of sense to keep Java relevant for the next 10 years. Yeah. So that's the second thing that happens is we've changed the release cadence, right? And so it's created a bit of confusion with end of public updates, which would have been a fairly routine thing with the new release cadence. And as part of that, Oracle has open sourced and is producing OpenJDK releases rather than having this binary code license that we used to have. So you may recall it's literally a 15-year-old license, the BCL. You may have heard of the general purpose computer clause, the field of use restrictions in that license. It was sometimes free, sometimes commercial, and we realized a year or two ago, this doesn't make sense. Why are we releasing Java under this semi-free, semi-commercial license when we could just release an OpenJDK build under the GPL? So starting a couple years ago, we started producing the Oracle JDK under the licensing regime that has existed for a very long time, the BCL and commercial use. But we started to produce OpenJDK builds with a goal of getting those together to be the same binary that we would either distribute to our commercial customers under a commercial license because they don't want to deal with the GPL, or as open source as an OpenJDK release. So we're there now. So we produce, if you go to jdk.java.net, you will get Oracle's OpenJDK builds under the GPL. So you don't have to worry about the BCL, you don't have to worry about am I running this in a dedicated purpose device? Is this really, is the cloud a general purpose computer? I don't know. You don't have to worry about any of that stuff, right? It's the same license as Linux, right? And then, so we moved to open source all the closed commercial stuff that we had. So we had flight recorder, mission control. We had a bunch of performance enhancements that we had kept in the Oracle JDK only around class data sharing. We were working on a deterministic garbage collector that was originally conceived as being a closed source commercial feature, but we've open sourced that as ZGC or ZGC. What do you say here, Z or Z? Z, Z, doesn't matter. So we've open sourced all that. But then the third thing that we did, so end of public updates of Java 8, new release cadence and Oracle open sourcing all of the closed stuff that it had before as OpenJDK builds. And then the third thing is we introduced a subscription product. So remember I mentioned Sun used to have this product called Java for Business? And then when Oracle acquired Sun, it was rebranded. And instead of this Java for Business, it was called Java SE Advanced. And it was sold by the Oracle middleware team. You see, this is one of these things where if I wasn't being recorded, I would tell you some things about the Oracle middleware sales team. But basically, it's a perpetual, I'm seeing some, let the record show that there's some knowing nods in the back of the room. But basically, this is a perpetually licensed product. It has a high cost, there's a lot of negotiation, and then you pay annual support and maintenance on top of that. And that worked great until a few years ago when it became clear the way modern applications and systems buy software is by a subscription. So we used to have this $5,000 a processor license with 22% annual maintenance and support. That's how we used to sell the Java support business, right? That's how if you wanted to stay on Java 6 and pay Oracle to give you those updates, that's how we used to do it. Okay. We've transitioned to a subscription model. It's $25 a processor a month, right? We've gotten rid of the old perpetual license, we've gone to a subscription model, and the reason for that is very simple. It's how people want to buy software now. It aligns with how you buy your Linux support. If you buy Linux support. If you buy Linux support, you can now buy Java support following the exact same model. And again, it's 25 bucks versus $5,000. But that gets perceived as, Oracle is now starting to charge for Java. And it's like, we haven't. It's simplified how we charge for Java for those that care, right? So those are the three things. Now let me kind of go through the slides and visualize a lot of this stuff. Any questions on that? At the risk of potentially rat-holing before I even get into the slides? We're good? Okay. And I should probably pay attention to the time, right? Pizza. Who do you order your pizza from? Oh, they're made here, okay, in the university or college. Okay. All right. So let's look at the release model. So I have one of the guys on my team has way too much time on his hands sometimes, but I have to admit we've presented this series of slide animations about 1,000 times, and so it's kind of paid off because it is a good visualization. But so this was the JDK release model plan. The plan always was we would do a release every 2 years, right? And that's always been our intent. And what you may not have noticed, unless you're really, really paying attention, or if you're an IT manager, you may have noticed this a little more particularly, but within that 2-year cadence, we have actually always had a 6-month cadence of feature updates. So when we released Java 8, it was like five months and a couple weeks later, we did 8U20, which had a bunch of features in it. And then 7 months later, just shy of 7 months later, we did 8U40. And then shortly after that, we did 8U60, and so on. And we're at 8U200 and something now. We've always had the 6-month cadence of features with security updates interleaved in there every quarter. So we do 4 coordinated security updates every year. And so like I say, we've always had that 6-month cadence behind the scenes. You just may not have noticed because you may have just picked this stuff up as part of your normal security baseline management. So when we launched Java 8, this was our vision of the future. In a couple years we would release Java 9. We would change the version numbering, of course, because hey, why not? See, there's another one I could go on a little bit of a rant on, but I won't because we're being recorded. But yeah, so we're this was our vision. But of course, things get delayed. Huge features that you're trying to bind to a particular release version need to be delayed for one reason or another, whether it's your own challenges with the new features in the technology, or whether it's you maybe have partners or licensees or other companies who are terrified of the change and are demanding behind the scenes for extra time. Things slip, right? And so we end up making these 3 to 4 year time frames. And again, you may not have noticed, but behind the scenes, after we do a release, we have a 6-month release lined up right behind it with some new features that go along with it. And so it begs the question, and I'm going to just flip back and forth on this animation a couple times just to try to draw a point here. I've been saying 8U20, 8U40 were feature updates, and they absolutely were. There was new things added, but there was never a spec changing feature, meaning we could not introduce a feature that required the JCP to approve a new specification, because you have to go through this whole JCP process with the expert groups. The expert committee has to vote on it. Of course, if you're adding an API or changing an API, you're going to have a lot of different opinions on how that should look and what the impact would be, and so on and so forth. So we could never do spec changing updates. And what we said was, well, again, if we want Java to be relevant for the next 10 years, in a world where we have Node, in a world where we have Go, in a world where we have Swift, in a world where we have Scala. Okay, I don't have to name off every programming language, but my point is there's a lot of competition out there, right? And so if we want to remain relevant, we knew we had to work with the JCP to streamline that process, and also especially with the folks at OpenJDK who work with us on those releases to make sure that we could do those spec changing features if we so chose on a 6-month cadence, right? All right, so basically the plan is, what we're going to do is those 6-month updates, we're just going to run them through the JCP process. We're going to, in terms of getting a specification, a reference implementation, a technology compatibility kit, and all that kind of work, what we're going to do is streamline things and be able to do that. And that's what we did. Now, we realize that, we look carefully at some of the Linux vendors and how they do long-term support. We look at Firefox and how they do long-term support, right? Firefox is another product, by the way, if you go back in time and look at, they changed their release cadence as well. We learned a lot watching what they had done when they transitioned from their release cadence to their current model, where they increment the main version number of Firefox, it seems like every second week, right? Yeah, so we realized we wanted to have at least one version every so often, every 3 years seems about right, that we would designate as a long-term support release, meaning that one won't get feature updates ever. Like after you do the release, then you do security updates, stability performance updates as needed, but no new features. The features just go into the 6-month cadence still. And that is for the conservative folk that want to stay behind on a legacy release like Java 6 or Java 5, okay? So if we throw it out in time a little bit, you can see we're targeting Java 11 is going to be a long-term support release. And again, this is from an Oracle point of view. If some other company wants to declare Java 12 as a long-term support release, they are more than welcome to do that, right? But we're declaring Java 11 as a long-term support release for our customers. And we're targeting 17, which is 3 years later. Hey, when we get to this point here, maybe we'll look at the market and decide maybe we should pull it in a little bit. There's a need, or maybe we'll push it out a little bit. But 3 years feels about right. So if we put the kind of the historical timelines on there, you can see that the long-term support releases kind of mirror the old model we had, where you can either get on the 6-month release cadence and always get everything for free, get the security updates for free, easy to do, keep up. Or if you wanted to stay behind on Java 7 or Java 6, you would have commercial support options for that. All right, now, simple. Let's color code it a little bit here. So the color coding here just goes into some of the license pedantry here. I'm happy to deep dive if anybody wants to do so, although I find in a room like this and slides like this, it's not the best way to do it. We can whiteboard during the break or after the fact. But what this slide here is trying to convey is, going forward, Oracle is producing OpenJDK builds. They are very high quality. They are as high quality as the Oracle JDK builds that we produce under the GPL on a 6-month cadence with security updates. So we do a release, it gets 2 security updates. We do a release, it gets 2 security updates. There's overlaps in there so that you do have time to transition between 10 and 11 and 12 and 13. The early access program has been greatly bolstered, so we have a release candidate for Java 12 that's been there for several weeks already. Java 12 GA's in a couple weeks. You could have already gotten a jump on what is almost certainly going to be the GA bit, so there's lots of time to overlap there and manage that. The red stuff is where we have the commercial long-term support option with a Java SE subscription. And the green bit there is conveying the fact that we're keeping Java 8 free for consumers. So if you have some sort of desktop app as an individual, you can continue to use that under the license that we will release in April. Okay, and then I put a different perspective on this. So so basically, you're either going to just keep up with the release cadence, just like you keep up with your Firefox releases every couple of weeks. Or you can, if you wish to, you can get on a long-term support release and still get commercially those same bits as we have on the 6-month cadence. All right. Any questions on this slide before I go ahead? Maybe I should have asked this 10 minutes ago, but is this new information or is this stuff you guys already knew? Or is this helpful? I'm not asking if you like it. So, okay, let the record show they laughed. But.
I saw it, but it's still helpful.
Okay, thank you. Okay. So again, we've been working hard in OpenJDK to make Java more open. We were on a path, like I say, up through the Java 8 release, where we had a group that was working on closed source features, and we were going to have a closed Oracle JDK that had value add. We realized that's not a good way forward. So we've worked hard to move things into the open. I think I have some slides on some specifics coming up. So when we talk about the new release cadence, it's really hard to wrap your mind around. If you have struggled, and I know I've struggled, I'm sure you have too. If you struggled moving from Java 6 to Java 7, or if you struggled moving, my last big struggle was moving from Java 4 to Java 5. Generics, oh my God, why do we need generics in a platform? Sun killed Java at Java 5 because of the complexity of generics. That's like actual, you can go back and find all kinds of articles about how that was the end of Java. But my point there is, on these major releases, we had, I wish we went further back in time, because there was actually like hundreds of major changes. So it's always been a challenge to keep up. But under the new release cadence, we haven't magically quadrupled our development organization and our ability to code features. What we're doing is, instead of releasing hundreds of changes at once, we're just doing it on a more incremental basis, right? And if we had a slide here that showed, like here, if we showed 8U20 and 8U40, it's actually like the same number as we're seeing in 10, 11, and 12. So, my point is, when we talk about the release cadence, when you hear about going from Java 10 to 11, it sounds scary, right? It's like, oh my gosh, that's a major release. But it's not a major release. We're shifting the language. Java 9 was the last major release. The releases after that are feature releases, and they're just 6-month feature releases. Now, that being said, moving to Java 9 is very challenging, right? It's probably the most challenging migration. If you're before Java 9, if you're still on Java 8 or 7 and you want to move to Java 9 plus, it's really challenging. And the reason, I'll have more slides on this later, but the reason is just there was a number of changes, not only with Jigsaw, but because of Jigsaw, we were able to improve some of the security and accessibility that we were exposing through Sun Misc Unsafe. And so, depending on what third-party even if you weren't using Sun Misc Unsafe, some libraries you depend on may have been. And we spent a couple of years trying to coax those frameworks along and had some success. But nevertheless, it's still an effort. But I'm greatly encouraged by, once people make the move to Java 9 or move to 10 or 11, how the transitions have been so far. It's been great. So one thing I've noticed is the IDEs, right? I was an Eclipse guy at one point, so I pay very close attention to what IDEs are doing. And it's really encouraging to see, for example, IntelliJ already supports the new stuff in Java 12. Right, before it's even GA. And so what I'm hearing is, from some friends at Eclipse, is it was always a huge panic in the last 2 or 3 months of a major release because, first of all, the Eclipse folks had to figure out, well, is Oracle going to slip the GA date? Like, how much time do we actually have? Or do we have 2 months or do we have 14 months, right? And we would send signals. It's like, no, we are like absolutely GAing on this date, and then it's like, oh crap, like we have all these new features that we have to be able to support because look how many features there are, right? So a lot of those are IDE changing things. And so it would be this huge panic, huge effort. You'd have to pull in a couple of dozen people with varying skill sets all over the place, work on it, and then they wouldn't have to do anything for 2 or 3 years, right? And all that knowledge would get lost. So this way, it's much more dedicated, it's much more routine, it's extremely predictable. If, for example, we had a feature targeted for Java 12, raw string literals, and we had a preview release of it. It was targeted for Java 12, and we got some really strong feedback from folks that we're not ready for this. Like, you forgot about this case, that edge case. What if you have 4? Oh man, I must be really tired. I'm forgetting the word for a tick. Apostrophe? Yeah. Yeah, so it allows us to just kind of jettison that stuff and just defer it to another release, right? So the idea is now we have a much more digestible release cadence, and the tools ecosystem has to go from this every 3 year or so panic to realizing they have to keep up and do much more routine maintenance. I assure you it's the same amount of effort, but it's now distributed more evenly, right? And I think in the long term, that's going to be a huge win. But it's a change, right? And I know a lot of organizations have to change, have to make these changes, and that takes effort. So, but again, I'm really excited by how well this is working so far. So. Hopefully we can continue that momentum, and when we're at Java 16, it'll just be routine at that point. And we'll be telling our children about that time we all had to move to Java 9 or later. So, okay, so let's go through some of these releases and a little more detail about what was in them. By the way, how many people here are actually running Java 9 or later? Okay, so there's a few folks, so most of you, I assume, are on Java 8. Anybody on Java 7? So, a couple. Anybody on Java 6 or earlier? Willing to admit it? Okay, that's good news. Yeah, Java 6 is officially end of life. So there are no more updates available to Java 6, and that was as of Christmas. All right, but here, if you look at the JDK 9 feature list, you can see why it's a challenge to move to, right? Like, those are all the JEPs, the JDK enhancement proposal. There's like hundreds of changes that you need to consider, okay? So that was a huge update. Now, Java 9, one of the, if you ask 100 Java developers what's new in Java 9, 90 of them will reply Jigsaw, right? And the other 10 will, I don't know. I was going to say something, but I'm being recorded. So, yeah. So, but the fact is, only these are Jigsaw related. Like, so my point there is, there's actually a heck of a lot more in Java 9 than just the module system and modularity. So there's a lot of other things went into that release. Java 10, 1 year ago, it was our first time-bound release, and it only had a dozen JEPs. Okay. Now, if you look at those JEPs, I don't know if you can see that. I do have slides on a couple of those at some point. But as an example, like, one of the JEPs is add root certificates as open source. So Oracle had a root certificate program, but it was commercial only. It was only in the Oracle JDK. People who were doing open JDK builds had to find their own root certificates. And often what they would do is just steal them from Firefox or do something in the operating system. And so it seems silly for Oracle to have its own proprietary set of root certificates, and so we worked with the root certificate vendors that we have relationships with, and we said we're going to open source these, and they all said fine because they want to be used in as many JDKs as possible. But my point there is that, like, that's a JEP, but that's not going to make it more difficult to migrate. If anything, it's going to make it easier for you to migrate. And if not now, certainly down the road. So there are some JEPs in here that are spec changing. So the local variable type interface, for example, is something that had to be carefully looked at. IDEs and tool chains had to consider what it would take to adapt to it. And they did. So there's a couple there, and that was a good proof point. We were very sensitive to what that first set of JEPs was going to be, to kind of show that people that moved to Java 9 would be able to slowly make those transitions. Another thing you'll see starting in Java 10 is our work on Docker. So we realized that Java is running in containers more and more and more. And so we've been working hard to provide APIs and settings to make sure that Java works well in a Dockerized or containerized world. It's often about a boot. It's a boot, how the JDK interacts with either the host operating system or the container manager for things like processes and memory. We also have Alpine support, so you can download Alpine Linux builds from Oracle of our Open JDK builds. We don't commercially support that, at least not yet. But it's just kind of a proof point of an area of investigation that we're pretty serious about. So you'll see features related to that starting in Java 10. And again, so this is an example of a spec changing feature that we would have otherwise had to wait for 3 years at least to release, right? We released Java 9. This feature wasn't going to make it until Java 10, 3 years later, if we didn't change the release cadence, right? And so this is mostly for readability, but it's basically the ability to use a keyword var instead of having to fully type everything. So when the type can be inferred, you can just use var. And it's one of those things where language purists will spend far too much time, in my opinion, debating the semantics of this and whether it's good or not for the language. But when you see community leaders like Lucas say, I've only been using this for a couple weeks, and I can't even imagine how I lived without it. That's a good sign. And nobody's forcing you to use it. You don't have to use var if you don't. That's my spoke is going a little crazy with the exhaustion. Yeah, that's my point, is some of these features you can have a strong opinion on, but we're not making you use them. So, all right. This slide would be here if somebody was jumping up and telling me that var was a horrible addition to the Java platform. Nobody's doing that. You all seem pretty chill here, so that's good. But Sorry?
We saw it in JavaScript.
We stole it from JavaScript. Yeah.
We saw it in JavaScript.
Oh, okay. Yeah, so one of the language guys on our team likes to point out that if you're worried about the readability because you use var and you're not sure what the types are going to be, like if you're looking at a code review, is like you should name your variables better. If it's okay. So these slides I will certainly make available. So I'm not going to spend. I have 70 or 80 slides, so we're not going to spend too much time on each one. Yeah, so application class data sharing, and again, this was something we were working on as a commercial feature that we open sourced as part of the new release cadence and building open JDK releases instead of this weird license we used to have. And so basically the way class data sharing works is it will ahead of time create a file that knows all of the class information, and it can just load that up a lot faster at startup so that it doesn't have to compute everything ahead of time, or sorry, compute everything on the fly. So yeah, so that's a good feature. We see lots of good feedback from folks all over the place that are really happy that they have AppCDS, because it improves the startup time of an app that you're going to be running over and over again. You know, in the EE world, something like AppCDS is like, you know, I start my app server every 2 or 3 weeks. It's not that big of a deal if it takes an extra minute to start up. But in the world of containers, in the world of functions as a service, in the world of continuous integration and deployment, something like AppCDS is really important. So also in Java 10, we saw an experimental Java-based JIT called GRAIL. Well, actually, yeah. And so that is available. This is, we should have somebody from the GRAIL team come in and do, or has maybe somebody from the GRAIL team has already come in? No? You don't remember? Has anybody heard of GRAIL before? All right, we got a few folks there. Yeah, so GRAIL is a product that's being developed in Oracle Labs, and it's virtual machine, high performance technology there, AOT. But one of the benefits of their research from Oracle Labs is they have a JIT that's written in Java. And so we can take that JIT compiler, use it in our OpenJDK and Oracle JDK releases, and we can see better inlining and performance because of that. All right. And yeah, at QCon, I saw a couple of sessions where people were talking about their use of GRAIL. It can be overwhelming, actually, for very certain specific kinds of benchmarks. So, you know, we've seen third parties like Charlie Nutter on the JRuby team. He's a big fan of some of the performance benchmarking that he was able to get. And again, it's not that it's 10% faster. It's like it's overwhelmingly faster, right, for certain types of applications. So we have that experimental JIT. You can try it today, right? It's just part of every JDK release after 10. Or starting with 10. Okay, how are we doing on time?
10 minutes.
Sorry?
10 minutes.
10 minutes, okay, good. I think there'll be a logical point coming up soon. All right, so another thing that we've been working on around the Java 10 timeframe is consolidating the JDK Forest. And this is, I don't presume anybody here is active in OpenJDK as a committer or an author. Right? But you know, we have several hundred people that work every day in the OpenJDK source repos. It's mercurial based, right? Which made sense a long time ago, and it still makes a lot of sense in a lot of ways today. But we do realize at some point we're probably going to want to transition that. And so we've been, you know, we have a project at OpenJDK called Sclara. Where they're investigating, you know, other source control management systems. And as part of that, we consolidated how we've set up and managed the mercurial repos that we use, which may seem like, well, how does that benefit me as a Java user? It makes our release cadence more predictable. And it will allow us in the longer term to produce higher and higher quality releases on that new cadence. All right, so that brings us to Java 11, which was released in September. Java 11 is the current release. Java 12 comes out in a couple of weeks. And Java 11 had 17 JEPs. And again, another example of a spec changing feature that we would have had to wait years for, but we can now get to market very quickly, and that's TLS 1.3, right? So it would have been an awkward thing to have to, because TLS 1.3 wasn't ready when Java 9 GA'd, and it would have been awful for the Java ecosystem to have to wait years before we were able to get TLS 1.3 out. So that's another proof point of the new release cadence and the value of it. All right, so building Java 11 together. So this is just an homage to all the organizations and individuals. There's a lot of individuals that don't show up here necessarily, but this is more about the organizations that contribute to OpenJDK. So this is just looking at the Java 11 release. SAP is one of the biggest contributors to OpenJDK. You don't hear about them a lot. A lot of their contributions are based on specific ports for their, I think I want to say PPC or AIX, Z390, like those types of systems where they have customers that have like 50-year support horizons, like airplane companies and such. So they're active primarily on that front, but also most certainly in a lot of other ways. Red Hat is also a huge contributor to OpenJDK relative to all the other organizations. And I can't remember if I have slides on this explicitly, so let me just take a minute to explain. So in OpenJDK, and this has been true since 2009, so it predates the acquisition of Sun Microsystems. So Sun and Red Hat had this format from years ago, where in OpenJDK, when we end of public updates, let's use Java 6 actually, because that was probably the first one. End of public updates of Java 6, the source code is all there in OpenJDK. Oracle stops making public releases of Java 6. It becomes a support only thing. But Red Hat continues to produce OpenJDK builds of Java 6 for their customers and their users. And what they're doing is, in conjunction with Oracle, they're working with us, they're backporting the work that we are making available with the security updates and continuing OpenJDK 6. And now they've are supporting OpenJDK 7. And actually, now that I remember, I do have a slide on this coming up, but they will be taking over OpenJDK 8, right? So that allows Oracle to continue focusing on innovation and the current releases and moving forward. And Red Hat helps keep those OpenJDK projects going. And again, working with us and the vulnerability working group to backport those issues. So that's why you see them show up there. Google, they also provide fixes mostly, so they're big into garbage collection. So we'll often get fixes and stuff from them on that. Oh, I guess we did count independent people. There's about 40 or so. And then, the long tail of other companies working in OpenJDK. So, all right, yeah. So we're talking about Java 11. How has the audio been? Good? I'm not too loud? Okay, good. All right. Are we good? Okay. All right. So welcome back. And for those of you that are watching this online, you missed out on pizza. It was delicious. So we'll pick it up. Oh, and it was from Grid Gain. So thank you, Grid Gain, for the pizza. Yeah. So we're going to pick up with Java 11. And I'm just going to go through some of the features that the more interesting of the features that made Java 7. And I went through earlier and talked about all the contributors. So one of the new things in Java 11 is the ability to basically execute a single Java file. So you can set it up that you double click on a Java file and it'll execute it. Or if you're into command lines, you can go and set it up that you can just run a single Java file. And the main motivation for this is, we want to become the next greatest scripting platform over Python. So, no, that's that is not the motivation. Although based on some of the visceral feedback that people had over this feature, you would swear that was the belief of what we were doing. No, really, it's just about trying to be approachable to new programmers. Just creating a simple way to be able to just simply run a Java file and not worry about the compile step, and just make it easier to experiment and play around. So has anybody here used JShell, which was introduced in Java 9? So in Java 9, we had a new feature called JShell, which is read event print loop REPL. It also makes Java quite approachable, because you basically get a command line and you're able to code Java right on a prompt on a command line, and try snippets of code really, really easily. So I use that a lot, especially if I'm doing demos. So this is just, it's another one of those things in that vein, just making it easier for developers to pick up. Okay, also in Java 11, we released the HTTP client as GA. So it had been incubating for a little bit. And it supports HTTP 2. So it just makes it easier for those of you that are writing HTTP-based apps. Again, TLS 1.3, an important security overhaul that didn't make the Java 9 release because it wasn't ready yet, the spec, the TLS 1.3 spec. So as soon as that was finalized, we were able to make that available in the next Java release, and so it's in Java 11. So you have access to some more modern cryptography algorithms. And it also obsoletes some of the older stuff that hopefully you're not still using. If you're into cryptography, if you do a lot of security, network traffic, and applications, I would recommend you follow the Java Crypto roadmap. And we actually host that on java.com. Mostly, normally our developer-focused content goes on OTN, but this one we wanted to draw special attention to. So if you just Google for the Java cryptography roadmap, we give you lots and lots of warning of when specs are coming along, when we're going to deprecate some older protocols, as the security industry deems them as no longer being safe. So we try to give lots of warning as that's happening, and the cryptography roadmap is a good place for that. This nest-based access control is one of those features where I'm like, I'm shocked that it's that important, but our architects and language designers and platform designers, they see they say benefit at scale at some of these seemingly trivial things. So basically, with this, the way inner classes were managed and created prior to Java 11 used a few extra bytes that weren't necessary. So, you know, in our relentless pursuit of continually optimizing for performance and memory, it was realized that we could take, you know, a fairly common inner class scenario like this and reduce the number of bytes fairly significantly, right? So it's like 20% fewer bytes on the person class there. And that adds up at scale. And it adds up if you're doing a lot of coding that ends up having inner classes, right? So if you're doing a lot of Lambda related work, you're going to get some compactness out of this feature. You don't have to do anything. It just automatically is taken care of for you. Also with Java 11, we open sourced Java Flight Recorder. So this used to be a commercial feature. So you used to pay for this. And now it's just part of the JDK and Oracle OpenJDK and any other folks that take the OpenJDK builds from us. Anybody here, by the way, use Flight Recorder Mission Control? One person. So if you haven't looked at this, you really should, right? So I can understand if you were reluctant to look at it before as a commercial feature, but now that it's free and part of OpenJDK, there's no reason for you not to have a look at this. So it's always on, and because it's an integral part of the JVM, it's very low overhead. So the goal is that it will never introduce more than 1% performance. And if you run into a problem in production and you've had the flight recording turned on, you'll get a tremendous amount of information out of that. So that's also new in Java 11. It's not a new thing, it's new that it's free. And it's new that it's open source, basically. So in Java 11, we also introduced ZGC, this a deterministic garbage collector. Although I guess we're not supposed to call it a deterministic garbage collector because it's not deterministic. So the goal here is to get as close to zero garbage collection pause times as possible. And we've actually been working on this for a long time. The developers for this are the same developers that worked on JRocket real-time. Does anybody remember JRocket? I don't know if any of you were using BEA and WebLogic, but another company that Oracle acquired. And so, yeah, so they've been working on that for a good while, and we're now seeing the fruits of that. All right, in the interest of time, I won't spend too much time on this. It's just faster. So I'll mention this, I think I have a couple more slides on some other features that are coming in Java 12, but you have a number of garbage collection options, which I think is a good thing because every application has a different performance characteristic to it. So being able to have some choice over how you manage your garbage collection, I think is a good thing. So we have 0GC, which is experimental. You can try that out like we have, it's weird. Lots of folks have been banging on this for a while and are seeing some amazing stats depending on the type of application. As you may know, G1GC was an experimental garbage collector in Java 8 in one of the updates, and we made that as the default garbage collector for Java 9 and later. There is in Java 12 coming a garbage collector designed by Red Hat called Shenandoah. Which also has some real-time-like characteristics. So I think it's good that we're seeing some competition as to who can make their garbage collector the least, pause the least. And then we were just talking at the break about a garbage collector called Epsilon, which is basically, it just turns garbage collection off entirely. So if you have an application where you know it's going to be so short-lived, or you're going to run a benchmark where you know you have a fixed amount of memory and it's no big deal, or you have some time-based app where you have lots of memory and you know it's not going to be a big deal, you can just plug in Epsilon garbage collector and not have to deal with any pauses whatsoever. So lots of interesting things happening there in the garbage collection space. So when we released Java 9, some benchmarks were slower than we had seen in Java 8. But there were some benchmarks that were definitely faster. So there was a bit of trade-off and balancing going on. And we knew that when we GA'd. And a lot of this was related to some of the work and improvements on Lambdas behind the scenes. And so we can see though that with the Java 11 release, the benchmarks, all of the performance benchmarks that we see are far superior than Java 8. So if you're still running on Java 8 and you haven't run a Java 11 runtime, VM and runtime on it, you should, and you may be pleasantly surprised at how much more performant it is. All right, so this is about migrating to Java 11. And I'm sorry if this is a bit, what's the word I'm looking for? Trite? Trite? Is that a word? Trite? Trite? Yeah, but is it the word I hope it means? I hope I'm not saying something insulting. But smug? Maybe smug. But basically, if you're looking to migrate to Java 11, read the documentation. So there's a couple of things, right? So one of the perceptions is, well, with Jigsaw and modules, I have to modularize my application now going forward. And it's like, no, you don't. Like, you really shouldn't have to make a lot of changes to your code, if any. Have a look at the documentation, and it will highlight what the changes are. So some things you want to keep your eye out for is if you were using sunmisc unsafe, you're probably going to have some troubles migrating from 8 to a later release. But once you do that, you're going to be good. Okay. There was a lot of things deprecated and actually removed in 9 and later, but especially later, so 10 and 11. So if you were using some of the EE libraries like JAX, some of the JAX libraries we had, some Corba has been removed. You're going to have to do this extra step of downloading those and adding them as a separate module, okay? And there's lots of examples of that. So that's another area you might want to look at as part of your migration. And so, there's a bunch of tools that are available online as well where they can look at your code. We provide tools. So we have a tool called JDEPS, and I have a slide on this coming up. I always forget the name of the second one. JDEPR. Usually somebody in the audience helps me out with this, but not going to happen. Okay, too full of pizza. So we have tools that will help you analyze your code and print out, here are things that have been deprecated or are scheduled to be deprecated. And we're taking deprecation a lot more seriously going forward because we know as a platform we have to remain as light and nimble as we can, to remain competitive in the cloud. So in addition to the obvious steps, the process we like to recommend, if you have a chance, if the QCon videos from this week go live, or you might be able to find it somewhere else online. Trisha Gee, you guys know Trisha, right? She's part of the LJC. She has spoken here, I'm sure. She did a talk yesterday talking exactly this process, right? So her first suggestion is just try to run your program on Java 11, and you may be pleasantly surprised. You will very quickly learn whether you need to update the libraries that you have, but you may also be pleasantly surprised that they are working just fine. In my experience, the more tied you were to the Sun Misc Unsafe class, the more work you may have to do here, the more libraries you may need to update. But otherwise, it's actually not as scary as it sounds. So once you get your application running, look at the warnings that have been generated and pay attention to them. We actually, we often get feedback in the support organization that, how do I put this? See, if I wasn't being recorded. So believe it or not, people rely they have build and test systems that actually rely on us generating a warning them that an API is being removed. And then when we remove the API, it's not that we remove the API, it's that the warning doesn't get generated anymore. So, all right. That was funnier in my head. All right, so yeah, and by the way, let me just go back here. So another thing to keep in mind here is you're doing those first 3 steps without even compiling it to Java 11, right? So I'm just talking about running the class files as they are, right? Because that should just work fine. And only after you have done, hopefully, not too much heavy lifting and moved your application up from 8, then you can look at compiling and then looking at the compiling errors or warnings that you might get at that point. All right, so people will ask me, well, should I move from 8 to 9 and then go from 9 to 10 and then 10 to 11 or whatever? And it's like, well, you could do it that way, but if I were you, I would move just straight from 8 to 11. The extra work that you're going to have to do is you're just going to have to read a couple of sets of release notes. One huge set of release notes for Java 9 and then a couple of small release notes for 10 and 11. And the analogy I like to use there is when you migrated from Java 6 to Java 8 or from Java 7 to Java 8, I hope you migrated to the latest version of 8 at that time, whether it was 8U20 or 8U40 or 8U60. I hope you didn't go to 8 and then go to 8U20 or 40 or 60, right? It seems unnecessary. So yeah, so that's what I would recommend is just jump straight into the latest release, whether it's 11 or if you don't get to it this week, 12. And again, I'm not sure how much this would apply to you folk here, but it would really benefit you to keep an eye on the OpenJDK project. So it's just openjdk.java.net. There are a number of mailing lists and resources that are available there to help you keep track of what's coming in the future releases. When people ask me what's coming in Java 13, I just go to OpenJDK, to the Java 13 page. I don't have to interact with the developers all the time, asking them what's in and what's out, because it's all updated in real time. And we do that because we are working with developers from a number of organizations, all of whom will have an opinion on what should or should not be part of a release. So that's my recommendation, is if you're keen on keeping up with what's coming and what we're working on, is OpenJDK, java.net. We have an OpenJDK Twitter handle. That's also a good resource to follow. That'll give you very targeted JDK related information. We of course have the @Java Twitter handle, but it's a little more broad, so it covers Java as an entire ecosystem. So you'll get EE related stuff, and you'll get all kinds of updates, developer stories and stuff. So it's a good channel if you're up for that, but if you're just specifically interested in the JDK, follow the OpenJDK Twitter handle. All right, so so the updates. So if you're used to getting your JDKs from OTN, that's cool. You can keep doing that. But you'll notice we're also encouraging you to just get the GPL versions of our binaries from OpenJDK. And so this is, sorry, I spoke at a sequence. I was explaining to you why you should go to OpenJDK and jdkjava.net. And now I have the slides that show that. But you can see it's a very, very simple, very straightforward download page, exactly like you would expect on a high quality open source project. And this is the slide, I referred to this earlier where I was talking about the updates project. So again, we've been working in OpenJDK since 2008. When Oracle acquired Sun, it doubled down on OpenJDK as a place to work on the reference implementation and source code of Java SE. So when we went through the end of public updates of Java 8 back in Java 6 back in 2012 or 13, we handed the project over, and so you could see that Oracle had worked on the 6 updates project and did that amount of work. And then we handed it over, and Red Hat said, yeah, we'll take over the updates of this project. You go work on Java 7 and Java 8. And then at some point, Red Hat said, okay, we're done with Java 6. So Red Hat stopped supporting Java 6 a few years ago. And they handed over to a company called Azul. And Azul took over the Java 6 updates project. So this pattern of working on the updates and transitioning the leadership has been around for a very, very long time. So yeah, so if you're interested, I don't know if anybody here is interested in the actual names of the people. Actually, Andrew Haley was at the conference yesterday, and we hung out for a bit. So it's all good community stuff that has been going on for a very long time. All right, so we have this long-standing transition process of handing over a project. We send emails about it. Okay. I can tell nobody cares. All right, so let's, for those of you watching online, if you're still watching online, nobody cared about that, so we'll move on. All right, so let's talk about Java 12. So Java 12 is going to be released in a couple of weeks. But spoiler alert, the release candidate that's there now, we are literally just going to rename it as the release, right? So, barring some, P0 or some other knock on wood issue in the next week or two. So yeah, so for all intents and purposes, Java 12 is good to go. And you can see we have 8 JEPs. Including an experimental JEP, and we have, a preview JEP, and then of course we have the experimental JEP, which I was talking about, Shenandoah, the garbage collector. So let's go into a little more detail. All right, so this feature that's coming in Java 12 is basically releasing memory back to the operating system, which is not something most OpenJDK and Oracle JDK builds ever did. So most Oracle JDK and OpenJDK builds, when it claimed memory from the operating system, it never gave it back. Right? So if your heap grew to a certain point and then it shrunk and you never really needed that memory, the operating system doesn't get it back. So starting with Java 12, we have a feature where we will be giving the memory back to the operating system. So if you have a bursty application that bursts up a huge heap and needs a whole bunch of memory, and then it calms down and doesn't need all that memory again, you can give it back to Chrome. Pause. All right. All right. So yeah. So you know, I know there's been some experiments with this over the years. There's some VMs and some folks that do this to varying degrees of success, but it's now going to be just standard part of OpenJDK. So that's good. The class data sharing feature. So you remember a few slides ago, I can't even remember if it was before or after the break, I was telling you that you could basically do all the class loading type behavior ahead of time and store it so that you could instantly recall it. Well, why don't we do that for the JDK by default, right? So starting with Java 12, for the 64-bit platforms, we're just going to have computed the class data set up so that when you start up the JDK, it just has this ready to go. Seems like something that could have done a long time ago with the app class data sharing, but one of the concerns here is just cross-platform compatibility. So because if you have an application that runs on one operating system, the way the class data loading works is going to be different than on another operating system, and so we just needed to work out the mechanics of that. So that is done. All right, so also in Java 12, we have a preview for switch expressions. So I don't know how familiar this kind of a ugly switch statement is to you, but we're making it easier to write more readable switch statements, but there's one more step from here where we can simplify that even further using the kind of the lambda symbol here. And basically you can get a much more readable switch. So, all right, so that is coming. That's a preview. That's a preview release. And like I say, the IDEs will support this. If you're using IntelliJ, you can already try that out. All right. All right, and then another feature that's coming in Java 12, and I got ahead of myself again earlier, I'm sorry, but it's the new garbage collector. This is largely developed by Red Hat. So we have ZGC, you have Shenandoah. You should experiment with those. Shenandoah is yeah, it's part of the JDK. I'm trying to think of something else to say. All right. So JDK 13, which is scheduled for September of this year, has 0 JEPs so far. So, which is good. It may actually be the easiest migration of any feature release ever in the history of Java. I do suspect we will have some JEPs that will come along there. But the point here is we only target JEPs when we have the features that we know are ready. And as of now, we don't have anything targeted for 13. Right? All right, so this is what again, I got ahead of myself, I'm sorry, talking about the JDEPs tool, which will help show the package level dependencies in your apps. But JDEPer scan, that's the tool I was trying to find earlier in my mind, allows you to scan your apps to find deprecated API elements that you can get a sense of when you need to remove those going forward. So one of the benefits of Jigsaw in Java 9 is we are able to do these incubator modules. So we're able to put out new features in a module that's clearly designated as incubator, subject to change, subject to removal. to give people a chance to experiment with it, provide feedback, and if it works out, then it'll graduate and become a full-fledged feature. Otherwise, it will get removed. And so, as I mentioned, Shenandoah is one in Java 12, and the switch expressions in Java 12, experimental. Okay, so let's talk a little bit about the futures. So some of the things that are in flight, but we don't have a target for these. As a product manager, of course, I'm always poking the team to try to get a sense of roughly when things are coming. But I think a good sign of success of the new release cadence is we don't have that pressure that we used to have before. We'll release it when it's ready. And I think it's a much better way of doing development. All right, so these are the kind of the main categories that we're working on. So I mentioned this at the very beginning. Containers. So we've been investing a lot in making sure we work well in the world of Docker and Kubernetes. And then performance. So I showed you some slides that showed you the performance just out of the box, the performance benefits you'll get from going from 8 to 11. It should just be faster. And we've seen that in the past, like going from 6 to 7, it was way faster. And going from 7 to 8, it wasn't way faster, but it was a little faster. And after a couple of updates, releases, it was even faster still. So if you go from 8 to 11, you should just automatically out of the box see a performance benefit. But we're working on things to blow that out of the park, right? So there's a number of projects that I'll talk about in that area. So we know that Java is huge in big data type applications. So we've been working hard for a couple of years now on some data optimization projects that I'll talk about briefly. Hardware acceleration. A few years ago, we had a project called Sumatra where we were working with, what was the name of that company? AMD, I think. Was it AMD? I think it was AMD. On basically running Java applications, especially big data type applications on floating, oh man, sorry, the jet lag is just absolutely crushing me right now. On graphics cards, video graphics cards, right? So you're able to offload, especially big data type applications off to these floating point graphical units. So we're seeing a resurgence in that again. So that project, we worked on it for a couple of years. We had some third parties interested in it that were leading it. We're starting to see some renewed interest in that. And then of course, scalability. We see Java running bigger and bigger applications with larger and larger memory demands and expectations. And then the other thing is the new release cadence. It's great because it allows us to do incremental changes to the language without having these massive changes coming every 3 years or so. So you're going to see these continual language enhancements, kind of like var. Right, where you don't have to use it if you don't want to, but it's convenient for those that do, right? So we have a number of projects with various code names in those areas. All right, so Project Portola, I did talk about that a little bit at the very beginning. And again, it's all about working in the world of containers. And yeah, so we've been working on Alpine, so you have a download there. I don't think I have anything to add from what I said earlier, sorry. Project Valhalla. So the idea here with Valhalla is, this is probably a fairly common model, right? Where you have a data structure of key value pairs where the keys and the values are just simple integers or longs or whatever. And the way that gets laid out in memory in the object model is it could be better. How would I put it that way, right? So we can streamline that. And that's the goal of Valhalla, is with value types, is there some way that we can lay these data structures out in an array or just, in a straight line, rather than having to traverse the object models, right? So we're going to have less memory, but also faster access. So that is a project that's been worked on for a couple of years. When this gets released, the impact is going to be huge, right? There's going to be a lot of applications that are just going to get way faster as a result, out of the box. We have a early access build of this, so I think it's based on Java 12, maybe Java 11, but you can jdk.java.net, you can go and already download some Valhalla early access builds. Project Panama, does anybody here have to use JNI? No? Okay, lucky you. So the comment I often get when people use JNI is it almost feels like it was designed on purpose to be difficult. And yeah, so the idea here with Project Panama is we realize that there are a class of applications where it makes sense to call out to some sort of native, ahead of time compiled library of some kind. So we see this in big data type applications, especially where you may have some, very low level library that's doing some hardcore computation that's just been optimized in a way that a JIT can't, right? And so with Project Panama, it'll be easier for developers to be able to access and leverage those low level libraries, right? So if you think about Hadoop, I don't know if many of you use Hadoop, but there's a lot of parts of the Hadoop ecosystem that are relying on system libraries and the JNI calls with the Java applications. And of course, anytime you say big data, you have to say machine learning now too. So, Project Loom. The chief architect of the Fibers project was actually at QCon today, and I went to his talk, and it was like a whole extra level of dimension. So some of this stuff, the guys that are implementing it, it's like one PhD is not enough to do this stuff perfectly, right? You need 2 PhDs. And when you get into this kind of stuff, and then you combine in some of the JIT optimizations, it's not an exaggeration that we're writing code to generate code that generates code, right? Like when you go all the way down that stuff, and is optimizing that code that generates the code, in real time. So. The idea here with Project Loom is, you're used to the threading model, and the threading model is great in Java, but when you have a bunch of blocking I/O type things, you run into scalability issues. Project Loom is all about dealing with that, giving you a lot more scale in how you do your concurrent applications and computations. And it's going to be fantastic in the world of serverless, right? So this is a feature where if you have a bunch of functions as a service and you're architecting your applications in kind of the FN function style, Loom is going to be a huge boon to that part of the Java ecosystem. And I think Project Loom, we're going to see that fairly soon, hopefully in the next year, I'd say, hopefully. So Project Amber this is one of these projects that's ongoing and is just always looking at language improvements. And like I said, we saw var. We were seeing switch expressions in 12. Raw string literals was another one that was targeted for 12, but then got deferred. And those all happen under the project Amber. So if any of these projects are interesting to you, by the way, you can easily go find them in the OpenJDK site and find the associated wiki, sign up for the mailing list, and just keep an eye. It's always fun to even just lurk if you have even just a small interest, because you never know when a mail might go by that will have something interesting there. Another project we have going that's forward-thinking is Project Skara. So, we have to remember that working in OpenJDK, it's not just about the project, it's not just about the JDK, but it's all about the all the work that goes into it. So Skara is just a project to investigate the SCM that we're using, and again, we've been using Mercurial. A lot of people love Mercurial. It has a lot of benefits, but it's clear that Git is the most popular and probably the easiest platform to go to if we're looking for broader participation and experimentation of the JDK and the builds that we're working on. So that is ongoing. We don't have a particular target in mind that we would do that. Did anybody here go to Open World or Oracle Code 1 last year? The Java 1 thing. I don't know if you saw the GitHub folks were up on stage, and we actually had a demo of for those that build their own JDKs. That's something I might have done at the very beginning as well, as ask if anybody here does build their own JDK. There's a lot of companies that do, right? I mean, obviously Twitter does. It's what powers Twitter. There's Facebook builds their own JDK. They have their own internal builds, and they're doing so mostly because they're focused on a scale that's pretty niche, right? A scale and volume that most people just don't have. So they have that going on. But projects like this help companies like that may be building and managing their own JDK for their own internal use. There we go. So you have early access to those projects that I was just mentioning. I don't know why we don't have a slide on JPackage, but has anybody here used JLink? A couple people. So JLink is a new feature in Java 9. I really should put the Java 9 features back in this deck, right? Then it becomes another 20 slides long. But so in Java 9, we introduced a new feature called JLink. And this is one of the benefits of modularity. Even if you're not using modularity, you don't have to modularize your applications if you don't want to. But let's say you create an application, you can use the JLink tool to strip out the modules of the JDK that you don't use. So you can make your application into a nice single bundle that includes the Java runtime, only the modules your application uses, and your application code, all in a nice single little zip file that you can chuck around the internet or deploy in a cloud or whatever it is you want to do with it. So that's JLink. But just in that general topic of making it easier for you to package and deploy your applications, we have a project called JPackage where we're looking at things in that area. Which, by the way, brings me to another common question I get with JDK, with JDK 11 is, where is the JRE? Because if you go to download Java 11, there's no JRE. And that can be a bit jarring, but if you haven't followed Java 9 and later, you need to understand that the methodology for deploying your applications has changed. You're not deploying your applications assuming the end user has a Java runtime anymore. You're deploying your applications with the Java runtime, and that's why we have the JLink tool. That's just modern application development, right? It's more and more operating systems with the sandboxing rules, especially if you're looking at Mac OS, we're heading to a world where having a standalone runtime from your application isn't going to work anymore. We need to think of these things as a combined thing for distribution. That's how it works in mobile. More and more we see that's how it works in the cloud. You deploy an application to the cloud, you're deploying a whole container, right? So we've made that transition in the Java ecosystem and the JDK, starting with JLink, starting with tools like the packagers that are coming, just to make it easier for you to package and deploy your applications. And we're just cutting the tie with JREs and just saying, no, you need to ship your application with that runtime. So, okay. JMC. So JMC is the visualizer of Flight Recorder. So Flight Recorder analyzes what's happening in your JVM, dumps out a bunch of raw data. It's really hard to read, right? So Mission Control is a nice GUI-based tool that allows you to visualize what was happening in your JVM. So JMC builds are there as well. So openjdk.java.net, that's where I'd recommend most folks go. I'm Donald OJDK. If you want to follow me on Twitter, please do. You're also, of course, more than welcome to follow any of the other folks on the Java platform group. Yeah, I think that's about it.